Hello everyone, today I'm super excited to solve a challenge from rareskills.io that involves the need to use so-called Metamorphic contracts, which is a very exotic proxy upgrade pattern for smart contracts where the code behind an address, a smart code address, is changing, but the address is staying the same. So we're going to need that to solve the challenge. I'll go in depth with what the challenge is, how we can solve it. I'll show you what a metamorphic contract is, how we can use an existing factory framework created by ZeroH, the head of protocol at OpenSea, and really go into detail with how the exact metamorphic contract deployment works. And we're going to look at the actual code for solving the challenge, which involves using the factory to deploy the metamorphic contract. Actually do the upgrade, the metamorphic upgrade, and you're going to get all the code to everything. So you can go and do the same. You can also solve the challenge, but you can do whatever you want. And specifically, you can see how the metamorphic contract works, not just in words or in a document, but in actual code. So really hope when you walk away from this that you know what metamorphic contract upgrades patterns are. You know how to do it specifically with the code. You can go clone the repo and you can do whatever else you want with these metamorphic contracts. I'll also touch a little bit about the danger of having this pattern. You have to be very careful, especially also as a user. If you interact with a metamorphic contract, it actually means that people can change the underlying code at a whim and keep the address the same. So you always want to be careful and check for that. So I really hope you enjoy the content. If you like it, click like, feel free to subscribe. I have a lot of other videos coming out with this kind of content where I educate on blockchain technology and just show you some in-depth code and everything. So the level kind of varies from beginner to advanced, but I hope that you find this helpful. Thank you very much. Hello, everyone. Today, we are going to solve a challenge that was posted by Rareskills. You can go to rareskills.io, check out their bootcamp as well. I did it myself. I highly recommend it. But basically, the challenge is posted right here in code. So we see right here, we see the constructor. It's payable. So when we deploy the challenge, we're going to put in 1 Ether from our own account. Later on, as you can see down here, we'll be able to get that Ether back. You see how they open an assembly block here, and in Yule, they get the balance of the contract, self-balance, and then they transfer it to whoever solves this challenge, which is messaged as sender here. Okay. So that's the challenge. So once we've set that up, we're out 1 Ether and we need to reclaim it by calling the success function and actually solving it. All right. So what's this about? Really, you can imagine we deploy a contract. It could be any contract. Just call it contract 1 or something. Okay. It doesn't matter what it is. We then, after we've deployed contract 1, call this initialize function with the address of contract 1. Okay. It's going to say, okay, it's going to do some checks here. Just one check saying, is the code at that contract or at that address greater than 0? Like, is the length of that code greater than 0? AKA, does code exist at that address? This is a way of checking this actually needs to be a smart contract address that you send in and not an EOA, right? So that's also saying, hey, it needs to be a contract. Then we take the code hash, which is the hash of the actual code base that's deployed at that address, and we store that locally here. And then we're also just going to store the address itself into this variable called strange contract. The contract is not strange yet, of course, but that's just the name. You'll see why. Anyway, so that's how you initialize this, right? So you set the variable code hash and strange contract. Again, against any contract, really. Now, we're going to have to be a little clever with what contract, but technically right now, there's no real limitations. Now, later on, we call success, which is this one. And as you can see, we give the address of another contract technically, right? But we will see some conditions that we need to impose in this contract. All right, so there are 3 conditions that we need to fulfill for us to solve this challenge. One is that contract we're given in also needs to be a smart contract. It cannot be an EOA. You see, we're checking the length. It also needs to be greater than 0. So we are passing in another smart contract with code. Another thing is that, look at that, the addresses need to be the same. So whatever we did to initialize, we stored the contract, needs to have the same address as what we're sending in now. So whatever the contract was before and now, they need to have the same address. Could it just be the same contract? So far it can, yeah. But here's why it cannot, because then in this check, we're actually checking that the code stored at that address location is different from when we initialized up here. So this contract and this contract needs to have different code. That's what this says. So we can't just initialize with one contract and then just call success with the exact same contract, because then this third check is not going to work. So somehow we're going to deploy a contract, initialize with that contract, and somehow have then do something and then have send in the exact same address, but now different code sits on that address, which, if you know about the blockchain, is a little bit weird, because normally we deploy a smart contract on the blockchain, it has some code and it's immutable. That address is always associated with that code and can never change. Now, so it seems weird, but that's the challenge. And then we get our ether back as we said earlier. Okay, so how do we do that? So the way to do that is to use a pattern called kind of a paradigm, if you will, called a proxy pattern, first of all, and a subset of that is a metamorphic proxy pattern. So metamorphic just means that it can kind of stem from morphing, right? It can kind of change. So it's like you have a contract at a given address that can change its code base, but keep the address the same. It's also sometimes called a redeployable contract. So you can redeploy it to the same address, but the code will change. So this, of course, in general is a very dangerous pattern. There are certainly use cases for it, but you got to be aware, especially as a user, that people can just change the code underneath you and keep the address the same is very dangerous. And some typical signs that this is going on is that there's a self-destruct in the code somewhere, because you will have to self-destruct before you can redeploy. So that's a sign that you just want to be a little bit careful. And then another thing you can look at is whether it's deployed from a factory that can do that, right? Or from a contract that can actually do that. Okay. Anyway, so that's the challenge. So to do this, what we're gonna have to do, and I've kind of put a few different things in here. I just need to zoom in here. There you go. In a nutshell, and a very, very high overview, and we'll get into more details with how it works, but in a very, very high overview, what we're going to do is deploy contract 1. Okay, we're just going to call it that. It's going to be a very simple contract. Doesn't really matter what it is. It's just a very simple contract. But contract 1, we're going to deploy. Then we're going to take that address and use as input to a so-called Metamorphic factory. This was created by ZeroAge, and I'll get into more detail with that. But we'll use that as input to the Metamorphic factory. We're also going to give the Metamorphic factory a salt, a kind of just a random value, at least initially random, and then we use that same salt later on, and I'll show you how. But deploy contract 1, use that as input to the factory, and then call a specific function in the factory that then creates a Metamorphic version of contract 1. Once we have that, in step 2, then we use the Metamorphic 1 contract. That's that address to initialize over here. Okay, so we're going to use that Metamorphic contract to initialize here. Fine. Then what we're going to do is we're actually going to self-destruct the Metamorphic contract 1. So we're going to need to have a self-destruct function in the contract to do it. Now that's self-destructed, we're going to deploy contract 2, which is another contract, and we're going to call the exact same function we did before, and importantly with the exact same salt value. So we're going to have to keep that around. And then we're going to deploy a Metamorphic contract 2. When the Metamorphic factory gets the same salt, it'll also deploy contract 2 to the exact same address. So the address will be the same. And then we're going to take that same address, right? And we're just going to put it in the success function. Okay. So yes, these addresses that we're going to give into initialize and success will be the exact same addresses. But this time around on success, we've self-destructed contract 1 and we've redeployed contract 2 on top of the address. So there, first of all, will be code. Yes. The addresses will be the same. Yes, we deployed it to the same address, but the code hash will be different because contract 2 will be a different contract. Again, it doesn't really matter what contract 1 and 2 are in content as long as they have different code hashes. And that's it. That's the challenge. This I made look really easy as an overview here. Just kind of, you just give the address to the Metamorphic factory and you just deploy Metamorphic contract 1. These steps here are very intricate, and I want to show you how. I want to actually dive into the details. So here's the anatomy of a Metamorphic contract. This is by A16Z Crypto. And I have these little colored markers that I want to just put on the process diagram here. So basically, the anatomy is very detailed here. We're going to cover that right now, but I want to just show you which is which. So you see you have a metamorphic contract factory to the left. You're going to send the code to this metamorphic factory. What code? That is the implementation contract code that you're sending. Okay. In our case, we're using a slightly different function on the metamorphic factory. Again, this is just a general metamorphic factory. We're using specifically the one from 0h, which I'll cover in a second. But we're using one that just takes the address, and then the metamorphic factory does the cloning. But I'll get into that. All right. Anyway, we send the code somehow to this metamorphic factory, the code of contract 1 in our example. And this is the metamorphic factory in our case, and this is in their case. And the metamorphic factory deploys this code, this contract that has this code. In our case, it's already deployed. So the metamorphic factory just clones the code, right? There are ways you can just like copy an external, like you can do ext code copy, right? You can just copy the external code. So it does that. And then it also stores the address of whatever contract it deployed over here. In our case, it's already deployed, so you just need to store the address. Like, in fact, you don't even need to deploy it over here to the left, right? Because it's already deployed. So you just copy it over the address and the code. All right. So then after that, we have the deploy contract. We have the stored address in our factory here, right? So step 1, 2, 3 are done. All right. Then what we do is, now that the metamorphic contract knows about the implementation code and everything, it can deploy its own version of that contract. So that's what's happened here in step 4. It deploys the actual contract, which is the metamorphic version of the implementation contract. So it's called the metamorphic contract. Okay. So now the factory has deployed that in step 4. All right. And during this deployment, so to speak, it just queries back to the factory and says, okay, I'm in the middle of deploying this metamorphic contract. The metamorphic contract says, okay, great, but what address does the implementation contract live on? Like, what code do I need to copy over? So it queries the factory for that address, gets the address of the implementation contract. Again, this would just be the address of contract 1, because we already had it pre-deployed, but it doesn't really matter. The factory still tells it, here's the address. The metamorphic contract says, great, now I'm going to go clone and copy the code from the implementation contract. Okay, so what we talked about earlier was just we needed that contract so that we can clone the code. Okay. Again, in our case, it's slightly different because here you're giving the code as an input, and then it does the deployment behind the scenes and all this kind of stuff, which we certainly could have done as well in this solution. But what I decided to do was just to deploy it and give the address, and then the copying could be done directly here, down to like the metamorphic contract could directly copy the code from the existing contract. Anyway, yeah, and so what's the yellow marker here? In our case, that is contract 1. Okay, if you want to have these color codes kind of be equivalent between the two, and then green is the metamorphic contract. Okay, all right, so that's how, I hope that was helpful as to what the metamorphic contract pattern is. You have the factory, it deploys a temporary version, if you will. This implementation contract is kind of temporary, and then the actual metamorphic contract will copy the code over from that temporary contract and then be deployed. And now going forward, if you send new code as input here and you just use the same salt value, it can actually update this metamorphic contract to another implementation contract code. Anything else really, but deploy to the same address. Okay. Great. So that's how that works. So how are we gonna do this? Well, I have the code here. Certainly feel free, as always, to look it up, clone it, copy it, do whatever you want with it. You could do your own metamorphic contracts. At least I hope it just shows you how to do it, like which functions to call, how to call them, and so on. Again, as I mentioned, is based on the work, great work by 0h, head of protocol at OpenSea. He had a Medium post on this, which I recommend you read. So I have the link in my repo as well. And then he does have his GitHub repo with the factory code, which is over here. Specifically, the function we're going to be using is deploy metamorphic contract from existing implementation. This just means we've already deployed contract 1. Like I showed you, it's already deployed at its own address. We just did that ourselves. So there is an existing implementation of it. We're gonna, when you call this function, and we'll show you how, we're gonna give a salt. This salt, if that just stays the same whenever you call this function, and you just give it new implementations, but you keep the salt the same, the address will also stay the same of that metamorphic contract. So that's how we can keep the address the same. All right. And then for this initialization code, well, we can just pick a very simple contract to solve this challenge that doesn't have any initialization code. So this can just be empty. How does this solve the challenge? Let's just go back here. I think we already answered that because when we deploy in step 2 here, contract 2, we're going to use the same salt as mentioned. And contract 2 is going to be this middle implementation contract. Initially it's contract 1. When we do contract 2, it's going to become contract 2. So imagine almost there's going to be a new implementation contract. And then the metamorphic contract is just going to query that address of contract 2. And it's just going to copy the code from contract 2. But the address is going to stay the same. So that's how we'll solve it. Okay, so this repo also, my repo here, will have the entire solution. All you need to do is just make sure the code is compiled. I used hardhat here. So you just do npx hardhat compile. And right after that, you can call node scripts and then solve challenge.js, and it will solve the challenge for you. But of course, we need to dive into the code and look at how it actually solves the challenge. All right. So I have the code here. And so the repo looks like this when you clone it. The README will be the one we just looked at. And as mentioned, we have a few contracts. So one is contract 1. Contract 1 is just a very simple example. All it does is add, it has a function called add, which takes in a parameter x and it just adds 1 to it, in this case of contract 1, and returns the value. That's it. And then it also importantly has a kill function that calls self-destruct. And the self-destruct just ensures that we can actually get rid of the code, get rid of the smart contract that is deployed to the initial address so that we can redeploy another contract on top of the same address. That's very important. And that's also why you have to, if you're worried that you're interacting with a metamorphic contract, definitely a hint that you might be is if there's a self-destruct. If there's no self-destruct, well, then it really can't be, because it needs to self-destruct to remove itself so that something else can take its place, okay? But again, self-destruct can be used in a lot of other contexts, so doesn't mean it's always being used in the context of metamorphic. Anyway, that's contract 1, very simple. We have the challenge here as well. So I just copied the code over. Again, clone this repo and you just copy the code or use it. This is the actual challenge code we just looked at in an image. So you know that. And then we have, by the way, contract 2, which is going to be the new contract. All we need to make sure of is just that contract 2's code hash is different than contract 1's code hash. All I did was just, instead of adding 1, now we add 2 in contract 2. It also technically has a kill function, which we don't really need because we've solved the challenge at that point, and we don't need to kill contract 2 to deploy another contract. So we don't really need this, but it's just to be a good citizen of metamorphic contracts, I guess, that we have it, so that if we ever want to deploy something else, we have it there. Anyway, good. So that's up. Now, I also took from CRH's GitHub repo, I actually took the entire metamorphic contract factory here, just copied it so I had it locally here. I just decided to do that. It's a little bit easier. I could kind of see the code more carefully in VS Code and all this kind of stuff. So that's how we're going to interact with it. And we're going to, again, as mentioned before, we're going to use this deploy metamorphic contract from existing implementation. Okay, so let's actually dive into the solution here. So if you go onto script solve challenge.js, this is where we're going to solve it. So first, we're going to do some setup. The setup just means we're going to deploy a bunch of contracts. So the first contract we're going to deploy is the Metamorphic contract factory. Note that the constructor to the overall Metamorphic contract factory, which is up here, right here, takes in a transient contract initialization code. The transient contract is the contract that sits in between. That actually, the transient contract is this basically. So this is kind of the contract that's deployed based on the code you send in. In our case, we don't need it. We don't need the transient contract initialization code because we already have the existing initialization or the existing code sitting at an address. So we actually don't need this parameter. So we could just send in like nothing, just 0x, doesn't matter. when we deploy the factory. Okay, so that's the Metamorphic factory deployed. And then we're going to deploy the challenge contract, because we're of course going to interact with that. So we're just going to deploy strange v4. Okay, challenge contract. Notice that when we deploy it, we're going to send it 1 ether. Hopefully we can claim that back later. We will when we solve it. But just note that that's the challenge to get that back. Then we deployed the first contract. Okay, so that's contract 1. Again, very simple. We can just add a number to it and comes back with 1 plus that number. Fine. Now we have the setup. Now we actually go ahead and solve the challenge. All right. So to solve the challenge, again, we need for the factory, we need a salt value that we can use with the deploy from existing implementation function. The salt value does need to include the deployer address, so the call this address more generally. So whoever calls that function, we need the address first, and then we need to just make sure that, so of course an address is 20 bytes. We need to make sure the whole thing is 32 bytes, so we can just concatenate it with something, anything really. I just picked zeros, doesn't really matter. Not very random, but it doesn't really matter for solving this challenge. In general, you might want something more random here. So anyway, that's our salt. That's very important to keep the same. So we're just to compute it once up front. We could technically make it a const here. And then you see on this Metamorphic factory, we call deploy Metamorphic contract from existing implementation. We're going to give the salt, and we're going to give the contract 1's address. Okay, so that's this address from contract 1 right here. Contract 1's address, that's what this arrow means. We're going to send it into the Metamorphic factory, and then we're going to have this salt, right, that we computed that kind of comes in as well as an input as we as we create this Metamorphic version, right? So the salt goes as input, the address goes as input, and that's what you see here. And then the last parameter is the basically the initialization code that'll go to the initialize function, if there is one in the contract 1. You see in contract 1 we don't have an initialize, but we could generally have like an initialize function here that takes some parameters, param1 and so on, with some types that I didn't specify here, and ... Something happens in the initialize, kind of like akin to a constructor, right? But for a more of a proxy contract. So anyway, we don't have that, so we don't have to pass anything. All right. Now that is deployed, we wait for it to get mined, and then when the deployment happens, I'll show you here. If you deploy Metamorphic contract from existing, the very last thing that happens is an event is emitted that's called metamorphs. And basically the parameters are, the first parameter is the deployed Metamorphic contract, so the address of the Metamorphic contract that was actually deployed, and then the implementation contract. So basically, the implementation contract. So again, in this diagram, what was the address of this contract here in between? Okay, good. So the point is, we're going to look for that event. One way to look for it is like this. You can actually take the receipt from having waited for it to have been mined. You can look for the events, and you can filter it by the name metamorphosed. And then you can get the arguments and the Metamorphic contract, because you can look under the arcs and Metamorphic contract. The arcs are, how do I know the arcs? Well, you can look at the actual event metamorphosed, and you can just, the zeroth argument is the Metamorphic contract. All right. So cool. That's the address of the, that's the address of the Metamorphic contract. Great. So now we deploy that. It's a Metamorphic contract. Fantastic. Now we just want to make sure that the deploy contract, the Metamorphic contract, is actually contract 1 and behaves like that. So that's what we're going to do here. We're going to say, hey, by the way, this thing that you just deployed, which we're going to call first address, this contract sitting here is actually a contract 1. So we're going to use hard hat ethers, and we're going to create a new contract instance, and we're going to say there's a contract sitting at this address with this API, with this interface, and this is actually just contract 1. So we're going to call add 1, and we're going to expect that when we add 1 to 1, we're going to get 2. And if we get that, well, great, that's contract 1 sitting right there. So we're going to make sure that's correct. And then having done that, now we have the Metamorphic contract 1. We're going to go to the challenge, and we're going to call Initialize with that address of the Metamorphic contract. And so it's kind of like we're going to register that code as like, hey, this is the code challenge, and we're going to change the code, but keep the address the same later on. So we initialize against the challenge. So again, this is the initialize we're calling. Okay, it's just going to store the code hash, store the address. Now, after that, we're going to make sure that we can't just immediately call success. Okay, so when we call success immediately after having initialized with the exact same address and the exact same code in this case, it needs to be reverted with contract isn't strange, because it needs to fail on this specific line because the code hashes are not different. Okay, and so it should. And then after that, we're gonna now kill contract one. Okay, contract one being the metamorphic contract from up here. We're gonna kill that. So it's gonna self-destruct now. Now there's technically nothing sitting, there's no code sitting on that address. So now when we call add one, it will be reverted because there's no code sitting there anymore. But now we're going to deploy contract two. Again, contract two just adds two to the number, so it's very similar. And then we're going to deploy contract two this time. Notice the c2.address this time. Notice the salt, again, is exactly the same. That's important. And we're going to look for the key event, or we're going to look for the event metamorphosed. We're going to look at the metamorphic contract argument. And that is going to be our second address, because it's going to tell us which address it got deployed to. Now, of course, the first address should be equal to the second address. So that's the whole point, right? That the addresses are the same, but the codes are now different. We're going to check that whatever sits at contract one, aka this address, this of course now is contract two, but we kind of instantiated the contract before and just called it contract one up here. But notice that now contract one is behaving a little bit strange, right? We're adding one and it's equal to three now. But that's because contract two is actually sitting on the same address as contract one originally was. Okay, so the code has certainly changed, but the addresses are the same, as you can see, because we can still use this contract one, which was instantiated against that old address, which is also the new address. Okay, now we're actually going to go solve the challenge. So we're going to call success, and we're going to use the first address. Again, it doesn't matter because second and first is the same, of course. And we're expecting it to not be reverted. And also we're expecting, so if it doesn't revert, we solve the challenge. But another tell is that the balance we had before in Ether has gone up. So we're going to store the balance before, and we're just going to expect that to be greater than before. In fact, by 1 ETH. But of course, there's some gas that was used in the call, so it's a little bit more complicated. But the point is, it's gone up. And the only way it can go up is if they send us some Ether, which is exactly the last step of that puzzle. And then we've solved the challenge at this point. So that's it. That's how you solve the challenge. That's how you deploy. You can look at this code. This is literally the steps for deploying an actual metamorphic contract. This could also be done, again, with any other code. You can do it on mainnet. You can do it on any other network and so on. I'm just doing it all locally here. But this is hopefully helpful so you can get the actual code for doing it. And then, you can use other, I just want to show you really quick here. You can use other ways to deploy Metamorphic contract. Again, I did it from an existing implementation, but as you can see here, you can also do it just from the bytecode, which is more akin to what A16Z crypto was showing, where you just send in the initialization bytecode of the implementation contract, okay? And then any potential initialization call data to the Metamorphic contract. But we didn't do it like that. It doesn't really matter. That's it. Challenge solved. We learned how to do it. Thanks for watching this video. I hope you learned more about Metamorphic contracts and specifically how they're deployed and kind of what they can be used to do as well. And the challenge kind of shows you the intricacies of the underlying code changing at a given blockchain address without the address changing. So I think that's super interesting. It's a very exotic proxy upgrade pattern, but it's important to know about. As always, let me know if you have any questions or comments. If you like the content, please click like, please subscribe. I'll see you in the next video.